Hello, this is Monika Sommerhalter. In this video, I'd like to show you how you can bring a picture to life, a picture from your textbook that shows a protein structure, in this case figure 13.6 in the signaling chapter, and this picture shows you the SH2 domain of a signal protein that can recognize phosphorylated tyrosines. The phosphorylated tyrosine is part of a short peptide segment. In addition to the phosphorylated tyrosine, you can also see an isoleucine, for example, 3 residues further up from the phosphorylated tyrosine that seems to interact with the SH2 domain. So to bring the picture to life, all you need is the protein data bank ID, the data that describes the structure, which is in this case the code 1SPS, and a web browser to activate a visualization program. We will be using iCn3D. So if you search for iCn3D, you should get to the web-based 3D structure viewer, and when you open the web browser with the iCn3D, then you can enter the PDBID code right away. And instead of the 1TUP, our code was 1SPS. And then I hit enter. What we'll be loading is 3 copies of the same type of entity. We have in pink one of the SH2 domains, and in blue the peptide that contains the phosphorylated tyrosine, and that same combination is shown 2 more times. That was part of the crystal structure that was deposited in the protein data bank. So step number 1 to explore is to simplify, and I want to only focus on the magenta or pink colored SH2 domain and its blue colored peptide that binds to the SH2 domain. So my first step is to go to select and to then define sets. With the same color coordination, you can see the object 1SPSA, the A chain. That's the one we want in magenta. What I don't want to have displayed is the one in brown. So I'm clicking on it, and now it turns yellow on the display because it's selected. To select multiple different entities or objects, I'm going to hold the Control key and then click on the C subunit. Then I jump over D because I want to keep D and select E and F. Now all the objects that I want to have disappear are selected. I'm going to press on View and Hide Selection. My view is greatly simplified, but I want to center in on the objects that are of interest. So I'm just clicking on the object A here and use the view menu again to first center and then zoom into the selection. In this picture right here, the presentation is very simplified, especially for this peptide that carries the phosphorylated tyrosine. So I need to modify the style of the peptide colored in blue. To do so, I'm going to mark chain D and then click on Style. My selection will be protein, and then I'm going to select spheres. I could also go for ball and stick, but to make it similar to the textbook image, we're going to select spheres. Everything is still colored in blue with the menu color. Instead of coloring by the chain, you can also color by atom. So if I click on atom, you will see all the carbons in gray, all the oxygens in red, all the nitrogens in blue, and the phosphate right here of the phosphorylated tyrosine residue that is in this orange color. With my mouse pad, I can zoom in so that you can clearly see that phosphate residue right now and how close it gets to some of the structural elements, to a pocket right in that SH2 domain. If you wanted to see the labels of this object, that peptide, right, we can click on Analysis, then Label, and I'm going to select Label per residue and number. The phosphorylated tyrosine has the number 0, and then going up and down, right, the numbers increase or decrease. Another residue of interest is that isoleucine number 3, so 3 residues from the phosphorylated tyrosine, because it also reaches closer to that surface of that SH2 domain. So zooming back out, the textbook image showed the protein surface of the SH2 domain. I can also do the same with this program. I will click on SPA. I might want to select a color that's not so intense, maybe selecting the overall object just in a lighter pink, and then going to Style, first setting the parameters of the surface opacity to have the ribbon still showing. I'm going to decrease it to 0.5, and then I like the wireframe presentation, but it's optional. And then I'm selecting a surface type, for example, van der Waals type of surface. So now we can see how the peptide snugly fits on top of the SH2 domain. And again, focus on the phosphorylated tyrosine right here, how that phosphate group reaches into a indent or pocket of that domain, which is called SH2. There are more options to make this image look more like the textbook. For example, I still have the SPSA chain highlighted, so I can adjust its color with a rainbow for the selection that I have active right now. So that would be another opportunity, right, to color code. Or you could keep it in a uniform color and give it a contrasting color, maybe now I'm switching it to a blue color. Of interest can also be to explore in more detail what type of residues on the SH2 domain actually interact with that phosphate group that is so important for signaling, right? Because phosphorylation is by a kinase is an important aspect of signaling. So I would like to know what type of amino acids from the SH2 domain form either hydrogen bonds or van der Waals contacts or ionic bonds maybe, sorry, with that phosphate group that reaches into the SH2 domain. To do so, we can press on the Analysis button and select Interactions. There are all kinds of interactions to choose from. There are the hydrogen bonds. If you have a checkbox, those will be displayed. Halogen bonds are not of interest. We don't have a chloride or bromide or anything like that. But we could leave all the other options open. You have a chance to modify the threshold. For now, we keep it at the default. Since I decided to color the A domain in blue, now SPSA is colored in blue. That would be one of my sets for the interaction, and the other set for interaction shall be that chain D, right, which is that peptide with the phosphotyrosine. There are different types of options to display the interactions. For example, just a 3-dimensional display, which will cause the generation of lines that highlight interactions on your graphic display. you can have an interaction table, and you can also have a shortcut, which is a 2D interaction network, and then some more options. Just looking at the two-dimensional interaction network, the residues are given with their one-letter code and the number in the sequence. In blue are all the residues from the blue-colored SH2 domain. In gray are the residues of the peptide. In the middle is that phosphorylated tyrosine. The phosphorylated tyrosine has a lot of these gray lines as well as the isoleucine. The gray color in your interaction table was reserved for just the most simple van der Waals type of contacts. The green color was for hydrogen bonds in the connecting line, and the cyan color was for salt bridges. So a lysine with the one-letter code K can form a salt bridge with a glutamate with the one-letter code E with its negative and positive charge. Right? The phosphorylated tyrosine also has intriguing interactions with arginine residues like arginine 12 and arginine 32. So this is kind of a nice shortcut to look at interactions in a different way. Now focusing on the interactions in the table, there are some opportunities to highlight the individual type of intermolecular interactions, for example, grouped by hydrogen bond pairs, or grouped by salt bridges, or just by the contacts. There are no pi cation or pi stacking pairs detected. So anything that you're interested to explore can be looked at in more detail. I am going to select one example with the arginine residue on the object 1-SPS, that's our structure, the chain A in position 12, and it's going to be the nitrogen atom in position epsilon. And this nitrogen of the arginine side chain will interact with the phosphorylated tyrosine residue with one of the oxygens of the phosphate group right here. And the distance between the two atoms will be 2.9 angstroms. So if I click on highlight, and then with my view button, I can view this selection. Maybe I'll make that window small for now, and also this one to have more room. And then what was zoomed in right here is really huge, right? I'm going to do the opposite, going out a bit. We see the branched chain of this arginine number 12 and how it interacts with an oxygen on the phosphorylated tyrosine. So if you know how to use one of these programs, right, you'll have a better chance to really know what's going on the molecular level with all kinds of protein molecules. In this example, it was the SH2 domain of a signaling protein and how it interacts with a phosphorylated tyrosine carrying peptide. So I hope you found that video useful and are now inspired to try out the software on your own. The name of the software is iCn3D. And I'll post the link on Blackboard. Then have a good evening. So see you soon in lecture. Bye-bye.